Good evening, my name is Pedro Cabrera, and since my date of birth is January 9th, 1998, I'll be doing problem 1. To begin with part A, we're asked to find the speed v of a water wave in terms of wavelength lambda. So we are given that speed equals square root of gk, and we want to solve that in terms of kinematic parameters. So let's begin by writing v equals square root of g over k. And since we can't have k in the answer, which is the wave number, we're going to transform k into 2 pi over lambda, as given in this hint through research as well in the book. So our new equation will be g for gravity over 2 pi over lambda, which lambda can be moved to the top, making it square root of gravity lambda over 2 pi. And that'll be the answer for this problem. Now moving over to part B, we're asked to find the speed v of the wave with wavelength lambda equals 8 meters. Now we will use this equation for this problem. So we have lambda equals 8 meters, and we want to find the speed. So v equals square root of 9.8, which is gravity, times 8 meters over 2 pi. And you will input that into the calculator and you will get an answer of 3.5 meters per second. And that is the answer for part B. And then in part C, we're asked to find period t for wave of wavelength lambda. Now, we are given a hint that the formula for period is lambda over v. So let's write that down. Find period in terms of lambda, also known as wavelength. So we begin by writing what we know, which is t equals lambda over v, which was a hint given. And I'm trying to focus. There we go. All right, so we also already know that v equals square root of g, which is gravity, lambda over 2 pi. So we can incorporate that into this equation. So we have t equals lambda over square root of gravity lambda over 2 pi. And now in order to simplify this, we can take the square root of lambda squared, which is just lambda, over square root of gravity lambda over 2 pi. Now, this can all go under one big square root, which would be, there we go, would be lambda squared over gravity lambda over 2 pi. And in terms of algebra, 2 pi can be moved to the top since it's a double fraction. So the new equation for t is t equals square root of lambda squared 2 pi over g lambda. And now since we have a lambda at the bottom and at the top, we could simplify that and cancel them out, giving us the finite equation of lambda 2 pi over g. All right, now moving on to part D. Excuse, I had to move locations for noise reasons. On the east coast of the United States, the National Weather Service frequently reports waves with a period of 4 seconds. Find the wavelength lambda and speed v for these waves. Now for this problem, I used two equations. I used this one to find lambda, the wavelength, and then once I had that, then I would implement it into this equation to find the speed. So let's begin by finding lambda with this equation. So we know the period on part D. Let's begin with what we know. Part D, we know the period is 4 seconds. So 4 equals the square root of 2 pi lambda over 9.8. All right, so in order to get rid of this root, we have to square the 4 and the root. So that would be 16 equals 2 pi lambda over 9.8. Now we multiply the 9.8 to move it to the other side and divide 2 pi. So it's 16 times 9.8 over 2 pi, and that equals 25 meters, which is lambda. All right, and now for the second portion, which is finding v, we'll use the equation square root of gravity lambda over 2 pi. All right, so we know gravity, we know lambda, and we know 2 pi, so we can just do the square root of 9.8 times 25 over 2 pi, and that'll give us the answer of 6.3 meters per second, because that's the SI unit for speed. And now for part E, which is pretty much the same problem with just different numbers. On the west coast of the United States, the National Weather Service frequently reports waves really swell with a period of 15 seconds. Find the wavelength lambda and speed v of these waves. So we will follow the same process, except we will have now a period of 15 instead of 4, equals 2 pi lambda over 9.8, and then 15 squared is 225 times 9.8 all over 2 pi, and that'll give us an answer of 350 meters for lambda. And now that we have lambda, we can solve for v with that equation of 9.8 times 350 all over 2 pi, which gives us the answer of 23 meters per second. All right, there you have it. Thank you so much.